Hello everyone, welcome to the new session. So this session is going to be the extended session of the previous session, okay? Because last time my phone, I was not able to record the whole video because my phone ran out of the storage space. So I guess last time on the video you can see we were done uh, up to here when we finished this graph, sketching the graph for y log of x to the base 1 by 2. Okay, 1 by 2. So today we are just going to observe few things. Now after that, what I did after I sketched graph for log of x to the base 1 by 2, then I did the same thing for log of x to the base 1 by 4. Okay, 1 by 4. So then this black color represents my graph for y equals log x to the base 1 by 4. Then if you compare both of these graphs, you can see that the value here is more than this. Okay, so I can say here that log of x to the base 1 by 4, it's greater than log of x to the base 1 by 2. And if you look here, it was opposite, like log of x to the base 2 is greater than log of x to the base 4. Okay, so if you will do the same thing for log of x to the base 1 by 6, then it's going to be here, log of x to the base 1 by 6. Okay, so that's what I did last time after the recording stopped. Okay, then here we said that because when we did the graph for log function, log to the base x, when our base is greater than 1, we said it is an increasing function. Okay, and here it's going to be the decreasing function. Why? Because if you pick any 2 points on the graph, okay, for example, just go for this red line graph, okay, red line curve, you pick any 2 points. Okay, for example, here I picked this point, this is named as x1, and here I have picked 1 point, this is named as x2. Okay, x2, this point. Okay, this point is known as x2. Now see here x2, now see here x2 is greater than x1, right? x2 is greater than x1, but because it is decreasing function, therefore if you look at the value of f of x2, means if you look at f of x2, so what is f of x2? F of x2 is negative, right? Negative, so it means it is less than f of x1. Why? Because f of x1 is the positive value of y. Okay, so why? Because it is a decreasing function. Okay, so in decreasing function, what happens is that the sign of inequalities, it gets reversed. Okay, because x2, see here, x2 here, the value of x2 is 3, right? 3, and x1 here is, this point x1 is around 0 point something, right? 0 point something. But if when you look at the value of the function, right, so it's going to be f of x2 is going to be less than f of x1. Okay, why? Because f of 3 is negative. Now see here, this, the value of y is negative, around -2, and x1, the value is positive, around 2. Okay, so in decreasing function, the inequality gets reversed. So I hope this thing is sorted. Okay, and here we are just going to discuss this whole thing in detail in few minutes. Okay, so let me raise this first and then we'll move to the next. All right. So our next topic is going to be increasing and decreasing function. Very, very important topic. That is the basis for your logarithmic inequalities. Okay, if you want to have a solid grasp on the logarithmic inequalities or exponential equalities, then you must understand like how things changes when the given function is increasing or decreasing. Okay, just hold for a second. All right, so the next topic it's going to be uh, increasing functions and decreasing functions. Okay, now if you remember, now we did graphs for both the exponential and logarithmic functions, right? So if you remember the graphs of both these functions, so here I can say that in increasing function, I will take the case of this exponential function, and this is going to be this is fx equals ax, right? And here a represents the base and a is greater than 1, right? And here I'm going to take the logarithmic function, right? Logarithmic function. And I'm going to take here logarithmic function. Fx equals log of x to the base a, where a is greater than 1. Okay, so if a is greater than 1, then what will happen? Then our graph is going to be like this, right? And here in decreasing functions, I'm going to take this one is going to be, it's going to be fx equals 1 over a x, and here it's going to be, okay, it's going to be fx equals log of x to the base 1 by a, where your base a, it belongs to any value between 0 and 1. I hope both these things are visible to you. Okay, now, so these two cases comes under increasing functions, and these two cases comes under decreasing function. Okay, now you can see here, if we look at the case for the increasing functions, here you can see that for both the exponential functions and logarithmic functions, okay, so we are only taking those cases where our base is greater than 1, right? Greater than 1. Now see here, so what make this increasing function special is that if you take any two values, right? If you take any two values on any of these graphs on the increasing functions, then we can observe few things which will tell us that why these increasing functions are specials. Okay, so here, for example, if I take two values, x1 and x2, okay, now anywhere you can take these values anywhere on this graph. For example, this is my x1, right? This is my x1, this is my x1, x1, and this is my x2, x2. Okay, so when I took these two values x1 and x2 on this graph, such that now see here, x1 is greater than x2, right? X1 is greater than x2. So if you check the values of y or value of the function at both these points, you will find here, see here, this is the value of y for y1. This is y1 and this is going to be your y2. So I can say that y1 is greater than y2. If x1 is greater than x2, then y1 is greater than y2. Okay, same here. You can take any two values. For example, this is your x1. This is your x2. Okay, so x1 is greater than x1 is greater than x2. Okay, so if x1 is greater than x2, then what's the value of y? F x1, it's going to be this y1 and this is y2. So we can say if x1 is greater than x2, then y1 is greater than y2. Okay, I hope you understand this thing. Okay, so here, if you observe one thing, you can see that in increasing function, the sign of equalities does not change. When you put function, when you add function on the equality or you remove function, the sign of inequality, it does not change. See here, x1 is greater than x2, then y1 is going to be greater than y2. Okay, it means that the sign just remains the same. Okay, so here, can I say this thing? Okay, so from here, can I say that here I can say that if x1 is greater than x2, then f of x1 is greater than f of x2, right? If x1 is greater than x2, then f of x1 is greater than f of x2. Or if f of x1 is greater than f of x2, then x1 is greater than x2. Okay, provided that f is an increasing function. Okay, so this thing is very, very important, right? This thing is very, very important. You have to understand this thing. Okay, so if you look at when you add function on the inequality or you remove function, okay, so the sign of inequality, it does not change. Okay, so this is very, very important property of increasing functions. Okay, now go to the decreasing functions. Okay, go to the decreasing functions. Now, in decreasing functions here, uh, again, you take any two values, for example, x1 and x2, okay, such that x1 is greater than x2. So here, for example, here I take one value, this is x1, okay, this is x1, this is x1, and this is x2, okay, this is x2, okay, this is x2. Now you can see here x1 is greater than x2, right? You can see here x1 is greater than x2. But when you check the value of the functions, okay, so what's going to be fx1? Now you can see here f of x1. What is f of x1? F of x1 is this small value, right? And this is smaller than f of x2. Okay, see here, if you do not understand it, what I did is that here I took x1, okay, so the value of x1 is this, okay, and here I took x2. X2 is smaller than x1, but the value of function fx2, it's going to be larger than the value of f of x1. Okay, so see here, f of x1 is less than f of x2. Okay, so same we can see for this graph. Okay, here, for example, here I took one value x1, okay, and here is my x2. Okay, now x1 is greater than x2. Yes, that's true. Now check the value of fx1. Now see here, f of x1 is this, means this is negative value, right? F of x1 is negative value, and what is f of x2? F of x2 is positive value, so it means that f of x1 is less than f of x2. Now if you look carefully, okay, then you can conclude in decreasing functions the sign of inequality, it's just get reversed, right? Here it got reversed, and here it got reversed too. Okay, so we can conclude one thing from here. Okay, so just for your own notes, so here I can say that if x1 is greater than x2, right, then f of x1, it's going to be less than f of x2, right? Because this is decreasing function, and when you remove function or you add function to the inequality, the sign just gets reversed. Okay, so same here, and if f of x1, right, if f of x1 is greater than f of x2, then what can we conclude from here? Then if f of x1 is greater than f of x2, then x1 is less than x2, right? The sign will get reversed. It's true. For example, if f of x1, if you take this is x1, if f of x1 is greater than f of x2, then x1 is less than x2. It's correct. Okay, so I'm going to put this thing here within the box, because these are very important. Okay, now we'll take some real-time examples to understand this scenario. Okay, so here I'm going to erase this part. Okay, so let's take here first. We'll take exponential function, and here exponential 2. Okay, so here we are just going to take base greater than 1, and here we are just going to take base 0 to 1. Okay, so this is let's say all right, let's say that uh, let's say okay, let's say that uh, I'm taking two numbers. Okay, here I am taking 6, and here I am taking um, 5. Okay, 5. Now see here, can I say 6 is greater than 5? It's obvious. Okay, so everyone knows that 6 is greater than 5, right? Because this number has more value than this number, okay? Because this is what math says. That's how math is defined, right? And here, if I say that 2 of 6 is greater than 2 of 5, then do you agree with me? Yes, that's true, because here I'm taking the function 2 raised to the exponent x. So if 6 is greater than 5, then can I say that 2 raised to the exponent 6 is greater than 2 raised to the exponent 5? 5. So that's what it says. If this is your x1 and this is your x2, okay, and if x1 is greater than x2, then f of x1 is going to be greater than f of x2. So of course this is f of this value is f of x1, and this value is f of x2. Okay, so this thing, if f is increasing function. Okay, so because we know that uh, the exponential function, the exponential function 2 raised to the exponent x, it's increasing function. Why? Because this is of the nature a raised to the power x, and a is equal to 2, which means a is greater than 1. Okay, so this function is increasing function, so it satisfies this thing. Okay, so it satisfies this thing. Okay, now go to the next one. Here again we are using the same thing. Again here I have taken two numbers. Can I use, okay, 6 and 5, right? And I can say that here 6 is greater than 5, because that's how math is defined. That's what math says, right? Now this is my x1 and this is my x2. Okay, x1 is greater than x2. Now here we are just doing it for 1 by 2 raised to the power x. Why? Because here my base, it is between 0 and 1. Now if I write it here 6, right, then here I have to say it is going to be less than 1 by 2 raised to the exponent 5. Now you can see here, because why? This is decreasing function, x1 is greater than x2, so when we added function to this inequality, then the sign got reversed. Now you can check it. This is 1 by 16 and this is 1 by 32, right? So which one is greater? Which one is going to be greater? 1 by 2 raised to the power 6. Sorry, this is 1 by this is 2 to 4, 16, 32, 64. 1 by 64. Okay, this is 1 by 64. So 1 by 30, yes, this is less than 1 by 32. So this means that, what does it mean? It means that, so this whole thing means that if you, this is, uh, this whole thing is f of x1, and this whole thing is f of x2. Okay, so from here we can say that if x1 is greater than x2, means this, then f of x1 is going to be less than f of x2. Why? Because if f is decreasing function. Okay, so see here, the sign of the inequality got reversed. This is very, very, very important thing when you are going to solve the logarithmic inequalities. You have to know, why did we write this? What's the logic behind it? Okay, so I hope this thing has this whole thing, it made your concept more clear. Okay, now we can take one more case with the logarithmic function. Okay, so let's see here. We'll take two more cases with logarithmic functions so that you have more understanding of these increasing and decreasing functions. Okay, so here I'm going to take two functions. Okay, so on the left side, I have here, I'm going to take fx equal log of x to the base a, and here a is greater than 1, base is greater than 1, and this x, it belongs to the positive, any positive real number. Okay, so here we'll take any two values. Okay, any two values. For example, here I will take here 1000, right? And here I will take 100, right? Now see here, clearly 1000, it's greater than 100. So this one, I can say this is my x1 and this is my x2, right? Now, if I take log, so with respect to base 10, both sides, okay? So this is going to be log 1000 to the base 10, and here log of 100 to the base 10. Now, this thing, because this thing can be written as, 10 raised to power 3, and this can be written as 10 raised to power 2. So this is going to be 3, because log of x raised to exponent n and log x, so this is going to be 3 log of 10 to the base 10. This is 2 log of 10 to the base 10. So this is 3, the value is 3, this is the value is 2. So you can clearly see that 3 is greater than 2. Right? 3 is greater than 2. So it means that if your x1 is greater than x2, then this 3 means f of x1 is also greater than f of x2. So if x1 is greater than x2, then f of x1 is greater than f of x2. If f is your increasing function, so you can clearly see here that when we deal with increasing function, the sign of inequality, it remains the same. Right? Now, you can come to the other case. We'll take the same examples. Here 1000, here 100, okay? And here we are just taking the case of fx log of x to the base a, where your base is between 0 and 1, okay? Now, clearly 1000, it is greater than 100. This is our x1, this is our x2. Okay, now if we take, okay, now here what we will do, we are just going to take the log both sides with respect to the base 1 by 10, here 1 by 10. Now see here. Now this 1 by 10 here, it can be written as log of 1000 to the base 10 raised to exponent minus 1, and this can be written as 10 raised to power 3. Okay, now same here, log of 10 square to the base 10 raised to the exponent minus 1. Now very interesting. So uh, th this is going to be here, and minus 1, it's going to be in the denominator. So it's going to be minus 3, and this thing is going to be minus 2. Okay, now this was x1, x2, x1 greater than x2, but if you look at f of x1, it is less than f of x2. Now see here, why? Because this is decreasing function, and when we deal with decreasing functions, the sign of inequality just get reversed. Here it was greater than, then here it is less than. Okay, so it means if x1 is greater than x2, then f of x1 is going to be less than f of x2. Okay, so I hope this concept is clear to you. All right. Okay. Okay, one more thing, and then we are going to conclude it. So I'm just going to erase it. All right, so let's say that we are given with the two things that you are going to use to solve most of the inequalities. Let's say that I'm given with this log of x to the base a greater than b. Okay, now log of x to the base a greater than b, and here I'm given with log of x to the base a is greater than b. Here the condition is that a is greater than 1, and here the base lies between 0 and 1. Okay, now this is increasing function. So okay, so when I'm going to remove log from here, so what should it be? It's going to be x greater than a raised to power b. Why? Because a is greater than 1. This is increasing function, so the sign of inequality remains the same. And here, because this base is between 0 and 1, and this is decreasing function, so here if I am going to change this thing into the exponential form, it's going to be x is greater than, I'm just going to remove the function, so x is going to be less than a raised to b. Why? The sign of inequality get reversed. Why? Because this is the decreasing function. If you understand this, you are going to understand this. Okay, and all these things are going to be the game changer when you deal with logarithmic inequalities. Okay, so just remember this thing. Okay, so I forgot one thing that we didn't do, but I will just take a few minutes to discuss that. Here I can write exponential functions. This is exponential functions, and here logarithmic functions. Okay, so the graph of your exponential functions are like this is here. This is y equals a raised to x. A is greater than 1, right? Sorry, no, a is less than 1. A is less than 1, and this is going to be your graph when when y equals a raised to x when a is greater than 1. Okay, on this side for logarithmic functions, okay, your graph is going to be like this. Okay, this is log of x to the base a is greater than 1, and this is when your log of x to the base a, where a lies between 0 and 1. Okay, now see here, if you look at the domain, because we didn't discuss it, because I thought I remember that in the last video when we did the graphs for this logarithmic function, then at that time I decided to do it, but then somehow it went out of my mind. Okay, so see here, so these are exponential functions, right? So a is less than 1. Sorry, this is going to be 1 by a raised to x. Okay, so uh, so here, what's going to be the domain? Domain of exponential functions and range. Okay, range of these exponential functions. So if you look at the domain, okay, this is x, this is y, this is x, this is y. Okay, so it can have, so the domain is that it can take any values from this side of x, and it can take any values from this side of x. Okay, so it's going to be minus infinity to infinity, right? And the range is going to be, look at both the graphs, these are going to be the two possible cases as far as exponential functions are concerned. So clearly the range is going to be from 0 to it's going to be from 0 to positive infinity, right? Because exponential functions, you know that the value is going to be positive. Okay, and now come to the logarithmic functions. Now, by definition, the logarithmic functions are the inverse of the exponential functions, right? So what does that mean? It means that their domain, the domain of exponential, is going to be the range of logarithmic, and the range of logarithmic is going to be the domain of logarithmic. Okay, so here, let's see here, domain of these logarithmic functions. Look at the x side of x. Okay, so it's just going to take the positive values of x, right? Why? Because logarithmic function is only defined for the positive real numbers. They are not defined for negative numbers. Okay, so here domain, it's going to be 0 to infinity, positive infinity, and range, now look at the range. Okay, so here you can see these are all the negative values on the side of y, and these are all the positive values on the side of y. So the range is going to be minus negative infinity to positive infinity. So see here why we say these are inverse of each other. Look at these things. Okay, so this thing is same as the range, and the range here is same as the domain. Okay, so that's all about these, the relationship between the exponential and the logarithmic functions. Okay, so that's all related to this. In the very next session, we are just going to solve the logarithmic inequalities. Okay, so have a great time. Thank you. Bye-bye.